1.3, functions and their graphs. This one we're actually going to divide into two sections. The first one with increasing, decreasing, constant, reflection on the x-axis, y-axis, even, odd, neither, relative minimum maximums. And on the second part, we're going to go over piece functions, evaluating and graphing them, and the difference quotient. But anyway, so let's get busy. Now let's say I have a graph that looks something like this, and I say describe the intervals on which the function is increasing, decreasing, or constant. The best way that I tell my students is consider a little man on the left hand side and read it left to right like you would a book. And if he's going up, it's increasing. If he's going down, it's decreasing. If he's horizontal, it's constant. Like, see, this one, the entire thing is increasing. So negative infinity to infinity.
All of these mistakes.
Then you have, let's say, we'll just keep it simple. Let's say this one. Left to right, it's always decreasing. So we're going to say decreasing. Negative infinity to infinity. And constant would, of course, be a horizontal line somewhere. That would be constant from negative infinity to infinity. Now, most of the time, the graphs is not just a line. I just started there. Let's say we've got a parabola. Notice how, and some of the students before, it has confused them when they saw the arrows, because they were like, no, that's increasing. So if you need to, mark out the arrows and just consider your little man. Notice how he's going downhill until you get to this spot. And your answer will always be the x-axis, never ever the y. But when you're doing your intervals, you're always going to do on the x-axis. So you're going to have parentheses, negative infinity to 3, decreasing. Increasing 3 to infinity. And notice how it's got parentheses with increasing and decreasing. You'll never have brackets or braces. It will always be parentheses. Let's do a good old basic like this one. I know I kind of did a little wonky, but we'll say, notice how from here, or all the way over till you get to 0, remember your man, increasing. So increasing negative infinity to 0. But then notice how from 0 to 3, it's ever so slightly going down. So decreasing 0 to 3. And then from 3 up, it's increasing again. Now, while we're here, I might as well go ahead and mention it. I said I was going to do it earlier. Notice how this graph, this is the lowest point. So that is the graph's minimum, because nothing goes below it. Well, if you look at this graph over here in x cubed, notice how we've got a low point here and a high point here, but it goes on to infinity in both directions. So what we can say is that this is a relative minimum and this is a relative maximum. In other words, it is a critical point. It's a point where the graph changes directions. It's just not the ultimate minimum, or like if your parabola was going down, we'll just move it over here this time. So see, this one has a definite maximum at the vertex or at that point. So while we're here, as far as if you have a critical point where it peaks for a little or sinks for a little, it changes its motion, that would make it a relative minimum or maximum. So this would be relative minimum at 3.1, relative maximum at 0.2. Because that's something they also cover in this section. Now this one, same again, if you wanted to do what intervals, let's say it's increasing from negative infinity to -3, decreasing -3 to infinity. And let's do one more. What about a weird one? What do we want to do? We'll say this. There we go. So this one, increasing, I think I counted 8, 4, 5, 6, 7, 8, yeah. Notice how it's not infinity, but it starts. Notice how it is still parentheses, always parentheses with increasing, decreasing intervals. Goes to +1, and then it's constant from 1 to, I think I counted 7. There you go. So that's the first half. Now the second half has to do with being reflected. Is it reflected around the x-axis or the y-axis? Is it neither? Well, notice how if we were to take just our basic y = x², notice how the y-axis cuts it in half. So we can say it reflects on the y-axis. And by definition, if it reflects across the y-axis, it is even. Now let's say this one, y = x³. Notice how it doesn't reflect on the y-axis. It doesn't reflect on the x-axis. But it reflects about the origin. So if it reflects about the origin, it is odd. So notice how it basically, if you were to flip this, it was an even, and then it flipped. Or in this case, technically, it's like that. Now notice how this one, let's say if I did x² + 1, if I went up 1 and then did a parabola, notice how it still reflects on the y-axis, so it's still even. But notice how if I said x³ + 1, if I went up 1 and did my cube, there's my origin. It's not reflected across the origin. So it'd be neither. Let's say I had x = y², a parabola going right at the origin. Notice how it's not even, it's not odd, but it does reflect on the x-axis. So that's how you can determine that as far as reflect on the x-axis, y-axis, origin, just by looking at the graph. So even, the y-axis cuts it in half. Now if it was something like y = x - 1², where you go right 1 in a parabola, that's a neither, because the y-axis does not cut it in half. So even, reflected on the y-axis. Odd, reflective on the origin. Now let's say they don't give you the graph, even, and you don't want to take the time to graph it, but you just want to know, given the equation, what's going on. Well, you can always replace x with negative x. If you do that, and it's the exact same, it's even. If you do that, and it's the exact opposite, it's odd. And if it's a mix, neither. So if I had, let's say y equals x squared plus 5x minus 2. If I replace every x with a negative x, let's see what happens. Here we get positive x squared again. Here we get negative 5x minus 2. So notice how when we compare, those are the same, but that one's the opposite, so neither. All right, let's say if I did 2x cubed plus x. Plug in negative x. So negative odd power, so it's going to keep the negative, negative 2x cubed minus x. Compare it. It's the exact opposite, so that means it's odd. Let me do one more and we'll see if you see a pattern. We'll see. This one. Even though I know it's up 5 skinny parabola, but let's act as if we don't know that. Or let's even throw an x to the 4th here just for fun. Well, notice how whenever you raise negative x to an even power, they're not going to change. So it's the exact same, even. So if you have, since that's an understood one, if you have odd, if it's a polynomial, it's a shortcut. It works with polynomials, not weird stuff, but your basic ones. If it's a polynomial and you have odd powers, it's odd. If you have even powers, it's even. If you have odd and even, it's always going to be neither. And the reason why is odd powers, your sign is always going to change. If it's an even power, the negative is always going to cancel and give you back your original. Now, notice how if you were to have a constant, like let's say plus 7, think of that as x to the 0, so you're still good. It's even. The trouble is you can't have, like if I said x cubed plus 8, 0 is considered even, so you have an odd and an even, so that's neither. So on the shortcut, just think constants are considered an even. And I believe that's all I needed to show you for the first half of 1.3. Let me give you the second half in just a minute.